Hello. Today we're going to talk about box and whisker diagrams. A box and whisker diagram displays the following information to summarize the descriptive statistics. So, a box and whisker diagram is going to give you the minimum value, the lower quartile, the median, the upper quartile, and the maximum value. These five pieces in the math world is known as the five number summary. All right. So, an example of a box and whisker plot would be a graph that looks something like this. All right. So, we know that this will be our minimum, this will be our maximum, this will be our quartile one, this will be our median in the middle, and this is our quartile three. All right. Those are the five pieces of your box and whisker plot. So, anytime we interpret a box and whisker plot, we can kind of decide what kind of shape it will be. So, as you can see here, we have histograms along with their box and whisker plot that's below it. So, as you can see here in the first box here, we can tell that that is a normal distribution, aka it is symmetric. If I split it down the middle, it looks the same on the left and the right. As you can see, my whiskers are the same length and my boxes are evenly cut in half. Okay. So that is what we consider for it to be symmetric. If we look at the middle box and whisker plot and histogram, we can tell that based off of the shape of this data, this graph is skewed to the right because it's skinny on the right hand side, or there's less data on the right hand side than it is on the left hand side. So this is what we would call skewed right. Sometimes you may hear being stated that it is positively skewed. Okay. And one way that we can notice that it's skewed right is that if you look at the box and whisker plot, the right whisker is way longer than the left whisker. Okay. If we look at our the third histogram and box and whisker plot, if we kind of trace this out, we can tell that this is skewed left because you have less data on the left hand side of the graph, and meaning it is skinny on that side. If we look at the box and whisker plot below it, the left whisker is longer than the right whisker. Okay, so these are just showing you how we determine the shapes. Okay, so let's look at this example here. So it says using this data set, we want to draw a box plot for the data. So what we are going to do is we're going to use our one variable statistics to find this information. So what we need to do is we need to go to stat, edit, and we need to put in our list of numbers like we normally do. So we have 36, 22, 41, 18, 36, 27, 31, 38, 25, 29, 22, 34, 48, 20, 12, 19, 35, 32, 41, and 50. So those are our numbers. So what we can do is we can calculate the five number summary. So what we're going to do is we're going to press stat, go over to calc, choose one variable statistics. We know that everything is typed in L1, so we can go down to calculate. So as we can see here, if we scroll down, we have our five number summary. We have our minimum, our Q1, our Q3, our median, and our maximum. So what I'm going to do here is I'm going to draw a number line and I'm going to label it by tens. So I'm going to label it 10, 20, 30, 40, 50. So I'm going to try to space them out evenly. So I know that my minimum is at 12. So I can pretty much say my minimum is going to be somewhere like here. My maximum is at 50. It says that my Q1 is at 22. So 22 is somewhere about here. My median is at 31.5, which is somewhere around here. And then my Q3 is at 37, which is somewhere in here. And it's not going to be perfect because I am drawing this by hand. However, I'm going to also show you how you can get this in your calculator, and you can also graph this in your calculator. So if we wanted to graph this in our calculator, the information is already put into L1. So normally what we do is once we put our data set in, we'll just press zoom, and then we'll go down to zoom stat, which is zoom 9. That means that is going to graph anything that's dealing with statistics. So when we graph this, we can tell that the graph is coming up blank. The reason why this graph is coming up blank is more than likely you do not have your statistics plot turned on. So if you look above the Y equals button, you will see it says stat plot. So we want to press second Y equals to get to the stat plot menu, and you will see that stat plot number 1 is turned off. So we want to press enter, and then we want to turn it on. The next thing we want to do is we want to make sure that it is going to give us the right type of graph. So we are looking at a box and whisker plot. So we need to go over to the 5th graph. So the one that's currently highlighted is the 1st graph, 2nd graph, 3rd graph, 4th graph, and the 5th graph. It's basically the second to last one. Once you press enter, it will select it. And we already know every value is coming from L1. The frequency is 1 because each number was typed in one time individually. So now if I go back to Zoom, go back to the stat, we will see that we have it here. So now all we have to do is hit the trace button, because if you move left and right, your cursor is not going to be on that box plot. So we want to hit trace. And as you can see, we see that our minimum is 12. It tells us that. It says the minimum is 12. If we scroll over, it tells us our Q1 is going to be 22. Our median is 31.5. Our Q3 is 37. And then our maximum is at 50. So now we can find the information and answer the questions in part B. So it says find the range. So we know that the range is your max minus your min. So max minus min. So if we want to find our range, we have to take our maximum, which is 50, and we have to subtract our minimum, which is 12. And we end up getting that 50 minus 12 is going to be 38. So that is our range. The next part is asking us for is the interquartile range. The interquartile range is equal to your Q3 minus your Q1. So we know that the Q3 is 37 and the Q1 is 22. So 37 minus 22 is equal to 15. So 15 is your interquartile range. So now for part C, it says find the percentage of data values that are above 37. So really quick, let's go back up to this sketch of this box and whisker plot. One thing that you need to understand here is that each section of your box and whisker plot is worth 25%. So 25% of your data lies in between the minimum and Q1. 25% of your data lies in between Q1 and the median. 25% of your data lies between Q3 and the median, and 25% of your data lies in between Q3 and the max. So if I were to use this information, if it says what percent of the data values are going to be above, if it says above 37, then all I have to do is highlight the section that is going to be in, and we already know that that section is going to be 25% because I only have 1/4 of the entire box and whisker plot shaded. Because once again, we know that 25% of your data is in this section. All right, so now let's talk about outliers.
So outliers are numbers that are really, really small or really large compared to all of the rest of your data values. So there are some formulas that we use to figure out the lower bound and the upper bounds to figure out when do we start becoming an outlier, or what number will we start becoming an outlier. So anytime you have an outlier, that number is going to be less than the lower bound, or the number is going to be greater than the upper bound. The way that you find your lower bound is you have to take your quartile 1 and you have to add 1.5 times your inner quartile range to it. And the way, or excuse me, it should be subtract here. Sorry for that typo. So it's your quartile 1, subtract 1.5 times the IQR. Your upper bound is going to be your quartile 3, and then you're going to add 1.5 times your inner quartile range. Okay. Anytime we identify outliers, we put a star or an asterisk on the box plot. So I want to make a box plot of the data below, and I want to make sure I identify outliers. So what I'm going to do here first is I'm going to go to Stat Edit. I'm going to clear out everything in L1, and then I'm going to type my numbers in. Remember, make sure you're careful when you type in your numbers in. All right. So there are all of my numbers. I have 17 numbers in the list, and I'm going to count to make sure I have 17 numbers on my paper. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right. So once I do that, I'm going to go to Stat, go over to Calc, and I'm going to run my one variable statistics. And we already know that we need to identify outliers, which means that I need to use my lower and my upper bound formula here. So in order to do that, I need to find my inner quartile range. So remember, your inner quartile range is your Q3 minus your Q1. So my IQR here is 23.5 minus 13.5, and that is going to be 10. So basically, I need to find my upper and my lower bound. So I know that my lower bound is going to be equal to my Q1, and my Q1 is 13.5. And then we're going to have to subtract 1.5 times the inner quartile range, which is 10. My upper bound is going to be my Q3, which is 23.5, and I'm going to add 1.5 times my inner quartile range here. So when I do that, I'm going to have 13.5 minus 1.5 times 10, and that's going to give me negative 1.5, and then I'm going to have 23.5 plus 1.5 times 10, and I will end up getting 38.5. All right. So that is my lower bound and my upper bound. So any number that is less, any number that's in the data set that's less than negative 1.5 is an outlier. And any number in the data set that is above 38.5 is an outlier. So yes, I do have an outlier. The outlier that I do have is 39. Okay. So if I wanted to draw my box and whisker plot, I would have my max and my min, of course. Now, 39 is the actual maximum, but remember, 39 is the outlier. So when we make our box and whisker plot, we are going to have to have our min, which is 3. We know that our quartile 1, and I'm going to go back and run the statistics again. We know that our quartile 1 was at 13.5. So I can label this as 13.5 here. And then we know that our median is 18. So I'm going to put my median like right here. So that's going to be 18. And then our Q3 is 23.5. So that's going to be somewhere around here. And we already know that our max is the outlier, which is 39. So when we represent 39, we're going to write it as a asterisk. And then the next number down from, 39, not 35, but the next number down from 39 is going to be 28. So 28 would be where that whisker would stop, which will be somewhere here. So that'll be 28 here, and this will be 39 here. All right, so that'll be how we draw the box and whisker diagram with the outlier listed. All right, so if you wanted to use the calculator to do that, it would not be hard. All you would have to do is go to stat plot, so second y equals. We turn the plot on, and we have to make sure to go to where the fourth one is, because as you can see, we see a box and whisker plot and we see little dots. Those represent the outliers. So once I select that, I can press zoom 9. And then as you can see here, when I trace my function or I trace my data, I see I have 3, and then I have 13.5, then I have 18, 23.5, and then I have 28, and then of course the outliers to the side, which is 39. All right. So last but not least, let's talk about parallel box and whisker diagrams. So anytime you are going to compare data sets, we use parallel box and whisker diagrams, and we normally have them on top of each other, okay, so that you can make a visual comparison. All right, so this is specifically for making a visual comparison. All right, so let's look at an example here. So it says the mock exam scores for 2 classes are listed below, and here's what we have here as far as these scores go. So the first thing that I'm going to do is I'm going to create me a number line so that I can kind of see what is going on here. And I see that my lowest value in each of these data sets, the lowest number that I see between all of them are like in the 40s. So I'm going to go from 40 here. And then I'm going to go all the way up to 100. So I'm going to have 40, 50, 60, 70, 80, 90, and then 100 here. So now I need to press Stat Edit, and I'm going to scroll up to L1 and press Clear and then Enter, and I'm going to put Class A in L1. So that's going to be 74, 98, 60, 72, 80, 91, 52, 73, 72, 66, 92, 68, 75, 66, 84, 82, 51, 74, 62, 59, 70, 93, 85, 76, 81. All right. For L2, I'm going to put Class B's information. So that's going to be 48, 100, 92, 100, 92, 92, 84, 68, 84, 92, 92, or excuse me, that's 92, 52, excuse me, 56, 88, 62, 58, 80, 84, 44, 88, 80, 68, 96, 88, 72, and 80 here. All right, so those are my values or my grades for the mock exam scores for the two classes. L1 is class A, L2 is class B. So it's telling me they want me to draw a parallel box and whisker plot for the data to compare the two classes. So remember, I'm going to be estimating. So what I'm going to do is instead of running the stat diagnostics, if you want to, instead of running the statistics, the one variable statistics, not stat diagnostics, but if you run the statistics to find your 5-number summaries, you can do it that way, or you can just have the calculator draw the box and whisker plots for you so that you can see what it looks like on the calculator. So if we do that, we can go to second y equals, and we're going to turn both of our plots on. So we're going to have on number 1, we're going to turn our plot on here, and then we're going to select the box and whisker plot, but I'm going to go ahead and select the one that includes outliers so that I can see if there are any outliers. If there is not an outlier, it's going to look like a regular box and whisker plot. So once I do that, I can go up and I'm going to scroll over to plot 2 and highlight it. And I want to cut that one on. And then I want this to also be a box and whisker plot that can show outliers. And I know that the plot 2 is going to be coming from L2. So I changed that from L1 to an L2 there. Once I do that, I can press zoom 9 for zoom stat. And then I can see both of my box and whisker plots there. So I can estimate where everything is. So if I press trace here, I see that the minimum of class A, remember class A is in blue. So if we go back to stat plots, we see that the first one was in blue, the second one was in red. Very similar to how when we do y equals and we see the colors. So if I look here and I press trace, then I see that for class A, and class A is going to be in blue here, I see that my minimum is 51. So I'm going to mark 51 here. And then I see that if I go over, my Q1 is 66, which is a little bit above half. I see that my median is 74, which is a little bit below half. And remember, I'm doing this by hand, so it may not be as accurate, but you should get the point. And then I see that my Q3 is 83. And I see that my whisker or my maximum is going to be at 98, which is somewhere here. So when I connect these two and I connect my whiskers, that'll be what I end up getting. The next one is class B here. Class B, if I press the down arrow, is going to take me down here. So I see that the maximum for class B is 100. Then I see my Q3 is 92. Then I see that my median is 84. My Q1 is 65. And then my minimum is 44. So now I'm going to make my whiskers, and then I can make my box here. All right, so this is a rough sketch of what I'm dealing with. So when it says that we need to compare, we're going to compare the spreads, and we're also going to compare the center. The measure of center that is here is the median. So basically, we can say that class B was the better class based off of the median, because in class B, 50% of the students or less 50% or less of the students scored a median score. And remember, that median score was an 84. Okay. So they were higher. So I'm going to say that based off the median, which is our measure of center, 50% of the students scored 84% or less on the exam. I'm going to say for class B versus only, and then the median for class A is 74%. So that is how we can compare based on the median. Now, if we wanted to compare based off of the ranges, anytime we look at our spread, we normally tell our spread based off of the IQR or the range. So I can tell just by looking visually that class B's data is more spread out, which means that it's less predictable. So class A, because they because class A's test scores are less spread out, that tells us that class A scores are more predictable, okay, in relation to the spread in the IQR and the range. So here I can just put that class A has scores less spread out than class B, meaning that the scores of class A are more predictable. All right. So if you have any questions on box and whisker diagrams, please let me know and I will be more than happy to assist you. Have a great day.